Let's recap. Venom is modified saliva that requires a wound to enter the target. The way in which this is achieved is through a venom apparatus, such as a stinger or modified teeth, such as fangs. So the plan was to go over the evolution of venom, but after a few days of reading and typing up more than 20 pages worth of information, I realized I'm unable to fully understand it, let alone explain it to you all. So I'll mention a few basic things and then we'll move on to the different types of snake fangs. Now, venom has evolved at least 25 times in several lineages, scattered all throughout the evolutionary tree. As I mentioned in the previous venom video, venom appears in both vertebrates and invertebrates. It's a key evolutionary innovation. Like anything in evolution, with sexual reproduction, errors can happen. If the mutation leads to a benefit through a new action, it becomes selected, refined, and amplified. Let's also recap the three main purposes of venom. One is prey capture, the example being snakes. Another is defense, such as a slow loris, the venomous primate. And then there's competitor deterrence. Last time I gave the example of how male platypuses compete for breeding rights of the female, but this time I want to give you another example. A fish called the fang blenny. They also use their venom for competitor deterrence. They hide within coral, and if another fish comes to try and take their hiding spot, they bite and inject their venom, which targets opioid receptors. The competition becomes high essentially, losing all survival instincts. So now they're out in the water column just swimming along, enjoying life, and they get predated on. That's one way to compete with another species, eliminating them completely, removing their survival instincts. That's incredible, isn't it? But these little fish also use their venom as defense against predators. So that just goes to show these three purposes of venom aren't mutually exclusive. Snakes evolved from within venomous lizards, and then diversified. Primitive snakes were venomous, but how come all snakes aren't venomous today? Thinking in terms of prey capture, being able to bite something, sit back, wait for the prey to die, and then eat. It's very effective, but it's also costly. The biological energy required to produce and maintain venom is expensive. Therefore, there's always a trade-off. If the animal's not getting a return on the energy invested, then that's a waste and puts them at a disadvantage against their competition. It's also energy that could be used towards other things. Other forms of prey capture involving mechanical restraint appeared. With these snakes, they no longer have enlarged dentition. Their teeth are only to hold prey as they wrap their coils around to constrict. What was once venom glands are now devoted to producing slime to aid in consuming prey instead of producing venom. It's a use it or lose it scenario. An example of this would be a species of sea snake, the turtle-headed sea snake. They now primarily feed on fish eggs, exclusively on fish eggs. Due to this specialized diet, there's no advantage in having larger teeth and venom glands. So these traits have been selected against, and now they have very small, reduced glands. Another thing I'd like to add about the evolution of venom being shaped by what they eat, so their diet, is looking at the type of snake, their behavior, and what they eat. Like specialists, for instance. King cobras, for example. They are snake eaters. So they specialize in eating snakes. So their venom works very well against snakes. Not so well even against lizards, because a snake's physiology is not the same as a lizard's. It's not the same as a frog's, not the same as us. But when you compare that to a sit-and-wait ambush predator, a snake that sits and waits, their toxins very complex. Maybe 20% of their toxin at that time goes after the prey that passes by them at that moment. So they're not going to waste an opportunity to feed, so their venom's much more complex. Death adders, for instance, they're a sit-and-wait ambush predator. They have one of the most complex venoms. Their toxins, again, only 20% may target what prey passes by at that moment, and they can't afford to wait. It could be another month or so before something else passes by. So this sensitivity in venom is what leads to those that are mammal specialists, their venom tends to be the most effective against us. So even though different physiology compared to the prey that they eat, the ones that specialize in feeding on mammals usually have the worst effect on us. It's amazing, isn't it? Now, I know this wasn't an in-depth explanation on the evolution of venom, but I hope you learned something from this section. We see how the shaping pressure of snakes is that of prey. Venom targets parts of an animal's physiology that leads to the loss of life quickly. With us, we are just collateral. They have no intentions of biting us and wasting their venom, but they will defend themselves if necessary. The belief that venom is for hurting people is just a ridiculous statement and not based in reality. They're defensive animals. But anyways, since prey is a shaping pressure, let's move on to how snakes get their venom into their prey. The different types of fangs.